If you can, well done. If you can take yourselves off screen for the moment, so I can start the teaching. Easy's gone. Thank you. All right, so I'm glad your mics are muted at the moment, because I need you to pay attention. And if you want to speak, obviously you ask any question you want and just bring yourself back online. That'll be fine. So this is congruent triangles. Again, some of you are beyond this, 2 of you are beyond this for sure, and 2 of you have submitted me the work as well. So yeah, that's 4 of you accounted for. Again, I'm class teaching, this is class work. Congruent triangles. The word congruent means absolutely identical to. Can't hear. It means identical to. So if you're given 2 triangles like this and they're drawn deliberately wonky and flipped over, if you can identify 3 matching sides as follows. Thanks, Han. Take yourself off the video now. If you can identify 3 matching sides, then these triangles must be absolutely identical. Same, you can take yourself off that. Thank you. So let's give a live example of that. If this is, for example, I don't know, 6 centimeters and that's 6, and these 2 matching sides are 5 and 5, and these 2 matching sides are 4 and 4, then you have got identical triangles, better known as congruent triangles, and that fits in with a rule that will always work. So it doesn't matter whether this has been flipped, rotated, translated, what's the other word? Yeah, I can't think of any more. If it's been moved around, it's been transformed any way you like, other than enlargement, then you can guarantee that these 2 triangles, however they're drawn, are identical or congruent. This is called the side rule, or for GCSE you can call it SSS rule, and everyone understands that you're not you don't mean anything else other than that. So there we go. First rule, side. I just pulled this off the net. They gave examples of an SSS rule. All 3 sides of triangles are equal in length, yet the 5 matches the 5, the 9 matches the 9, the 7 matches the 7. All that is pretty and colourful. I didn't like it because I should have taken the purple one and maybe rotated it or flipped it around or something like that to make it look like a bit of a challenge. But if you've got 2 triangles with corresponding sides identical, then they are in fact identical triangles. And I sort of prefer this one because here at least they try to sort of pretend like it's been maybe reflecting in that sort of mirror line there. So 7.1 matches 7.1, 3.5 matches 3.5, and this one here, 5 matches 5. These triangles are identical, they are congruent because of the SSS rule. Is that all right? Rule number 1 done. Here's the second one. Again, this is my drawings, then I'll download some other stuff. Here we have an angle matching an angle, another angle matching another angle on the triangle, and so far we don't know if they're congruent. However, if I give you the length of the side right here and it exactly matches the length of the side right here between the 2 angles, it's called the included side. This side is included between the 2 angles. So if you've got this situation and you're not sure whether they're identical, trust me, they are. Have I got an example of that? Let's have a look. Yes, I do, so I won't overdo this one. This is called the angle, side, angle rule. Let me show you. Angle, side, angle. Now going the other way. Angle, side, angle. If these are the same and all these 3 things match and the side is included between the angles, you've definitely got a pair of congruent triangles based upon the ASA rule. Over here, just downloaded this one. It's not a problem, it's easy. I've got an angle, a side and an angle. An angle, the side and an angle. Don't bother reading all this. This will be on the video. I never call it AAS, ever. I call it ASA. So these are identical because if you've got 2 7s as bases and you've got a 65 and a 65, Okay, just to let you know, Tyan, when you come in here, switch off your video. You're 10 minutes late. You've disrupted me a bit. So we've got a 65 and a 65 and a 40 and a 40. See, the direction in which this line travels and that one as well is fixed by this 40. The direction in which these two lines are drawn is fixed by this 65, which means that the meeting points of both these two triangles will be identical. And obviously angles in a triangle add up to 180, so the missing angle, which is about, say, 105, 75, shows that they're identical because of the size of the base. Okay, so this is angle, side, angle rule. Next one. Yeah, this is why some people like to use the general rule, angle, angle, side. Question: are these two triangles congruent? They're saying yes, they are. But why are they congruent? Simple reason. Let's call up a yellow. This is 75 degrees. That is 75 degrees. And look what I've got here, guys. I've got angle, side, angle. That matches that angle, that side, and that angle. So really, this is an ASA, but you need to do a little bit of work to find the third angle to absolutely guarantee that the 5 centimeter length is included between the two angles. All right, so that's why that's important. Next one. Yeah, are these two identical? Are they congruent? What do you think? Let's test it, shall we? If they put the little line right there, I'd be really, really happy. They stuck it out there. So what's this missing angle right here? Anybody know? Just work with me quickly. I don't want the video to be unnecessarily long. What's there? Thank you. That's a 60 because add up to 180. This is the same. That's a 60 as well. And now I actually believe them. I've got an angle, a side, and an angle, and I don't care how long that is. They're just telling me by those little cuts that we're the same size. So ASA, and I've got an A, an S, and an A. It matches, therefore they're congruent because of the ASA rule. Done. Next. Yeah, this is different. Don't get confused. If I have a triangle or a pair of triangles where they have one side that matches and another side that matches, and the angle between those two sides becomes an included angle, then I promise you these two triangles will be congruent stroke identical. This is called the side angle side rule, or SAS. There's the side, there's the angle, there's the side. There's the side, there's the angle, there's the side. Different from ASA. And here's an example from this slide here. We have a length or a side that matches a side. We have an angle that matches an angle, and the side that matches a side. Please note this angle is between the two sides. This is the included angle. Very important. How do you spell that? It's very difficult to spell when the pen slips everywhere. Included, yeah, it's very difficult. Included angle. So let me just say it rather than write it. Here you go. That's meant to say included. It's still written in ancient Egyptian, but anyway. So included angle, SAS. And this, you won't recognise that, but it's actually a screenshot from the Maths Watch DVD that I'll be buying for you lot next year, which you should fall in love with and learn. Question: are those two triangles congruent, yes or no? Somebody have a little think, somebody have a little speak. Are they congruent? Are they identical? Is he? Neha, you've done the homework. Are these two triangles identical? They are. Actually, no, why not?
Because I haven't got the same
Doesn't matter. That's not the reason. Yeah, they haven't got the same length, but we don't know that actually. But just based upon the information you've got there, are these identical? Are they congruent? Do they follow the SAS rule? Yes or no? The answer is no, because really the included angle is not given. Had they said that matches that, now look, side, angle, side, side, angle, side. These two angles are not included between the two sides. Therefore, they're not congruent. We don't know. We don't have enough information. So at the moment, we have to say not congruent at all. Please note the angle must be between the two sides. It must be included. Is that all right? Got to be included. So no, they're not congruent. And this is the last one, which you won't have heard of because they have not included this in the Year 9 scheme, but it's essential for GCSE. And the next time you will see this topic is in Year 11 when we do geometry, not in Year 10. Look at this one. If you're presented with two right-angled triangles and you've got two matching sides that correspond to each other, then you have definitely got a congruent pair. These are identical. This was called the right angle hypotenuse, which you know from trigonometry, the long side is hypotenuse. It's called the right angle hypotenuse side rule, or RHS. Here's a live example, and this is why it works. Well, I've got a right angle for each one, for sure, so I'm going to tick you off as done. I've got an 8mm base for each one and a 10mm hypotenuse for each one. According to the rule, the RHS rule, they're completely identical to each other. This is an interesting comment. This rule works, why? Because of Pythagoras for 90-degree triangles. And that means that the missing sides can be calculated. So I could work out this missing side if I needed to with a calculator. It will be 10 squared, take away 8 squared, hit the square root button, and you get the same answer for each. So really the RHS rule is nothing more than a SSS rule. Yeah, side, side, side. Because once you worked out the missing side, hey, you have got the SSS rule that's come out of it, and that's really, really important. It's good, which is maybe why they don't include it in the Year 9 scheme. However, we don't apply Pythagoras to this in Year 9, so I teach it as a separate rule. I always have done. This is a graphic which I downloaded, and they're sort of testing out the RHS rule. They have told us we've got a right angle. Yes. They've told us S1 and S2 are the same, so that matches. I definitely have a tick on that. I've got my right angles sorted. I need one more side. Oh, I need an H. So that H matches that H because they told me so. Yeah, it's definitely right angle hypotenuse side. So they are identical, they are congruent. Now we need some audience participation. These are the rules that I have taught you so far. SSS, ASA, what's the other one? ASA, I said SAS, so dyslexic. So ASA, SAS, and RHS. And that's the 4 rules of congruency. We need to apply them to question 1, which is taken from a sheet somewhere. Look at number 1. State the condition that shows that these are congruent. Why are they congruent? What's the evidence? Ty, do you want to come in? Henry, do you want to come in at this point? Are you there, Henry? Because I can't hear you. How do I show the participants, by the way? Because I've removed them so I don't have to. Okay, I don't see the word participants anywhere. Anyway, maybe later. Does anyone know quickly where I can find it? Anyway, I'm not going to waste time with that. So those who are here participating speak. That includes Henry and Tyann. So for question 1A, these are congruent. Why? Ibrahim, teach. That's all you have to say. It's not side, side, side angle. There's no angles given. It's just the SSS rule. Amen. Done. Right, who can we ask next? Henry, are you involved? Are you here? Henry, can you do that one? Maybe Henry's not here. Tyann, are you actually here? Who am I speaking to right now? Who's speaking right now? Okay. Which rule is it, Subhan? Which one? Say again. Bad angle side. Where'd you get bad from? Say it again clearly. I agree. SAS. Somebody else do me a C, please. Well, I prefer ASA because it's angle, side angle, angle, side angle. Yeah, it is AAS, but ASA is way better because it describes the direction in which we move. Thank you. Anyone want to try D? Zaim, have you spoken today? You don't have to be sure, you're here for the lesson. So, what do you reckon? No, because I don't know what that side is. I've only got two sides. So no, SSS don't work. Well, it does by Pythagoras, but what's the initial rule? It's RHS. I've got a right angle, I've got a hypotenuse, and I've got, let's have a look, I've got a right angle, I've got a hypotenuse, and I've got one other side that matches, RHS. Somebody talk me through 1E. They're definitely congruent, but I need a bit of thinking behind this one. Tyann, are you here? Yes or no? Henry, are you here? Yes or no? Interesting. They're not here. Okay, I'll have to mark him as absent. And neither is his actual camera. And what about Tyann? Is his mic not working? Can somebody ask him? I'm trying to conduct a lesson remotely. This is magical, truly magical. I have no evidence that they're actually present, other than it says 13 up there. Right, E then. So somebody give me an E answer for that, if you possibly can. What about Hamza? What about E, Hamza? Well, give me some more evidence based upon the diagrams, because, yeah. Possibly, but I don't like AAS at all. I know you said ASA, but I need a little bit more evidence than that. You need to talk me through it, because you've not mentioned an included angle. I don't even know if I've got an included angle unless I do some further mathematics on it. And guess what that further mathematics is? And that would, what would that give us? Yep, there's 21 right there. And same story here, there's 140 right there. A bit hard to draw. Look at this. Now give us your evidence. Now give us your evidence. I don't have any sides there, and I don't have any sides there. Good. Angle, side, angle. Same angle, same side, same angle. And the 10 is proven to be included. It does say at the top that they're all congruent, and you have to just sort of give your reason for it. So now we're going to go over to someone. Anyone else? Emma, do you want to get involved in this? Just the last one. Are they congruent or not? Well, they are congruent, but why? For sure, but why is that true? Well done. Well, like it's just got mixed units. You don't usually see that at GCSE, but here it is. Yeah, this is just an SAS that's been a little bit hidden because of that, and that. But yeah, they're both SASs. Brilliant. Now, I think the next little bit is going to be extension-y. What I've done is taken a screenshot of that, cropped it, and put it on a Word document. Anyone who does the basic classwork, which, as you know, Brandon, Tyann, Henry, wherever you are, as you know, it's EX1, page 212, question 1 and 2. You don't draw anything. What you need to do is do what Neha has done, and has scanned the page, cut it out, and stuck it in her book. Now, Hamza, you're getting very, very good at cutting little triangles. They look ever so beautiful, and it's very pretty to look at and very cute. But you're going to go mental trying to cut out 1A, then 1B, then 1. Don't do that. Just stick the whole page down in your book and do the work on the right side of it. Is that okay? That's all you need to do. And same with question 2. In fact, I'm very happy for you to put the answers straight on the diagram. So for question 2, how long is A? How long? Just write it straight on there. Provided you can send me a good evidence of your work, I can see clearly what the answers are, and I'll be able to spot errors. So yeah, that's fine, Brandon. Do that as well. So for 1A, for example, are they congruent? All we have to do is say yes, it's SAS. Simple. Is B congruent? Are they congruent? No, because the included side is a different length. Yeah, you can't have a 5 and a 3 and claim that they're going to be congruent. They're not. So that's all there is to it. If you can't be super neat, then obviously print out the page and do the working on the side. But everyone everyone is going to get this. Right, I'm reaching my 40-minute limit, so we've been going for a long time. I better just stop sharing, but just like I said, this is going to be given to everyone who's done the classwork, and if you do it, you do it. If you don't, that's fine. You know, I'm not worried about that. But Henry, I don't want you to get bored, so what you need to do is to actually do this and send it back to me.